All right, this next section is going to talk about two items. It's going to talk about the quadratic formula, and then we're going to go over the discriminant. So quadratic formula, remember you're given a quadratic equation, which is ax squared plus bx plus c equals 0. And the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, the most important thing with these is that you make sure that you identify what your a, your b, and your c are before you do anything, because that can definitely impact everything. And all of your answers always need to be simplified completely. So in this case, the problem we have is it's not equal to 0. So the 33 has to move over first. That then allows us to identify our a, our b, and our c. So again, those are the leading coefficients that we're working with here. So now what I'm going to do is I'm going to take each of these values and I'm just going to sub it directly into the formula. So negative 8 squared, 4ac, all over 2a. So 8 plus or minus 64 plus 132 over 2, which is 8 plus or minus radical 196 over 2, which this one comes out nice. So I get 8 plus or minus 14 over 2. So that's 8 plus 14 over 2, and that's 8 minus 14 over 2, which gets me two answers of negative 3 and positive 11 for your final solutions. Okay, I'm going to do different colors here so they don't get mixed up. All right, in B's case, everything's in the right spot to start with. So we just go straight to subbing it in. So definitely this would be one where a calculator would be needed. So just make sure you have one next to you as you're working. 4ac, 2a. Oops, this is minus, sorry. And what you're going to find here is when you start to simplify, the number underneath the square root sign is 0. So you get 34 divided by 2 because there is no square root, which just gets you 17. So what this would mean is even though it only looks like one solution, this would be your instance where you have a double root going on, just like we did when we were factoring before. All right, with C, everything's good. So we have A is 1, B is negative 6, C is 2. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So we get 6 plus or minus radical 28 over 2. You're going to be simplifying radicals here. So 28 is made up of 2, 2, and 7, which is 2 radical 7. And then what you find is 6, 2, and 2 all have a 2 in common. So you have to make sure that you simplify each one down. I don't need all the extra 1s going on in there, but just make sure that you have 3 plus or minus either 1 radical 7 over 1 or just 3 plus or minus radical 7 for the final answer there. So A had 2 solutions, B had 1, but it was a double root. C has a radical in it. So let's see what happens with D. So I'm going to move the 6x over first. And then A is 1, B is negative 6, and C is 13. So then I get x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I get 6 plus or minus radical negative 16 over 2. So we see a negative under the radical, which means we're going to have i's. So x equals 6 plus or minus, well, negative 16, radical 16 is 4. So radical negative 16 is just 4i over 2. And similar to the last one, 6, 4, and 2 all have a 2 in common, so we want to make sure that we simplify that. So we get x equals 3 plus or minus 2i. So those should be our solutions. If you want to write them separate, absolutely. If you want to keep them together, you can do that as well. All right, part 2 to this is going to talk about something called the discriminant. The discriminant is actually the value underneath the radical in a quadratic formula. So that is your b squared minus 4ac. So again, it's the value under the radical, or the square root sign. So when we talk about discriminant, there's 4 scenarios that we can encounter. Okay, if the discriminant, or if b squared minus 4ac was greater than 0 and a perfect square, then you're going to have 2 real rational roots. So 2 real rational roots. If your discriminant, b squared minus 4ac, is greater than 0 and not a perfect square, and not a perfect square, then you're going to have 2 real irrational roots. If b squared minus 4ac, so your discriminant equals 0, then you're going to have 1 real rational root. And the fourth one is if b squared minus 4ac is less than 0, which means it's a negative number, you're going to have 2 complex roots. So what the next set of examples is going to do is it's going to have you find the value of the discriminant and then describe the number and type of root. So we're basically calculating first and then taking the chart above and identifying what we have. So for A, just like we had done with the front page of the notes, we got to first get everything equal to 0. A is 1, B is 12, and C is 4. But the nice thing is we're not actually calculating the solutions. All we are doing is focusing on the discriminant, which is b squared minus 4ac. So that's 12 squared minus 4 times 1 times 4, which puts me at 144 minus 16, which is 128. So that is a positive number, but it is not a perfect square, which means discriminant is 128. There's my first answer, and that leaves me, because it's not a perfect square, with 2 real irrational roots. So this is column 2 on the chart. In B's case, everything's in the right spot to start with. When I sub in b squared minus 4 times a times c, I get 16 minus 176, which is negative 160. My discriminant is negative, which means I'm going to have 2 complex roots. So this is column number 4 on the chart above. For C, here's my values. B squared minus 4 times A times C. I get 49 plus 32, which is 81. Well, 81 is positive, so it's greater than 0, and it's a perfect square, so I'm going to have 2 real rational roots. And for this last one here, I get 9, negative 6, and 1. B squared minus 4 times A times C. I get 36 minus 36, which is 0. So my discriminant is 0, which means I have 1 real